Hi, today I'm going to talk about the very first Nobel Prize winner in chemistry, a man whose unusual name is matched only by his hairstyle. Let's dive into the story of Hoff in only 3 minutes. Jacobus Henricus van Hoff, whom I will refer as Jacobus, was born on August 30, 1852 in Rotterdam. He was of course a curious and passionate child who chose to study chemistry to oppose his physicist father. He received his technical degree from Delft University of Technology and then his doctorate from Utrecht University in 1874. It was there that he established his first theories, which he had the good idea of publishing in a small French scientific journal. I say good idea because I don't speak Dutch. 30 years earlier, Louis Pasteur had shown that certain molecules, such as tartaric acid, could crystallize in two forms, mirror images of each other. These two crystals interacted differently with the light, which made it possible to separate them. Jacobus studied these crystals and realized that whenever this type of asymmetry occurs, a carbon atom is connected to 4 different atoms that form a tetrahedron around the carbon. Imagine! At that time it was thought that molecules were flat and that it was simply their stacking that gave them 3D structures. Jacobus proposed that molecules themselves are 3-dimensional. His outlandish theory was heavily criticized by the scientific community for about 10 years until it was realized that it answered many questions that were still unresolved in the field and even led to a new field of research called stereochemistry. But it was not his theories on stereochemistry nor their impact on organic chemistry that earned him the Nobel Prize. It was his work on chemical kinetics and osmosis. Let's start with kinetics. During his experiments, Jacobus observed that some chemical reactions can take hours, while others take only few seconds. He then established equations linking the concentrations of molecules to their reaction rates. Okay, but what is the point of knowing if reactions are quick or slow? Imagine you are a manufacturer of adhesives or cement and you want to optimize the setting time. Imagine you are a pharmacist and you want to estimate the speed at which a drug works. Imagine you are a car manufacturer and you want to predict the speed at which mixtures burn. Shall I continue or you are convinced? Well, that was it for kinetics. Now, let's talk about osmosis. Imagine a bag containing a mixture of molecules concentrated in a liquid. This bag is immersed in the same liquid with the same mixtures of molecules, but much more diluted. Last but not least, the membrane of this bag allows the liquid and some of the molecules to pass through. This kind of membrane is called a semi-permeable membrane. Under these conditions, the liquid will be absorbed into the bag to balance the concentrations. This concentrations balance is called osmosis. Okay, but the same as kinetics, what's the point with osmosis? Let's take a concrete example. The cells of a human body are, in simplified terms, pockets filled with water and molecules enclosed in a semi-permeable membrane immersed in the variation fluids of the human body, which are mainly composed of water. Osmosis therefore explains the interactions and exchanges between cells and all the fluids in the body. In summary, chemical kinetics has applications in the chemical, pharmaceutical, automotive and other industries, and osmosis provides a better understanding of exchanges in all living beings. It is therefore entirely normal that in 1901, at the first Nobel Prize ceremony, Jacobus Henricus van Hoff received the Nobel Prize in Chemistry, I quote, in recognition of the extraordinary services rendered by his discoveries of the laws of chemical dynamics and osmotic pressure in solutions. Well, that's it for the video. Thank you for watching it. If you like it, feel free to comment, share, like and subscribe. See you!